I am Henry and I will be presenting on the effect of dyke emplacement on host rock deformation. Nearly all volcanic eruptions are fed by dykes and sills which propagate through the crust. Magma supply, ascent rate and rheology are known to control the dynamics of propagating magmatic intrusions and consequently may directly influence the duration, style and potential climatic impact of volcanic eruptions, although a significant proportion does not reach the surface. Host rock deformation is significant due to how it relates to emplacement processes and the preserved records. Deformation during emplacement has previously been investigated via multiple approaches, including analog experiments, macro-scale observations of joints, faults, and micro-scale observations. This project aims to build upon this work describing the evolution of microfracture networks and their structural characteristics within quartzite and marble host rocks surrounding foliatic dykes. I have done analysis in multiple locations for comparison. However, due to the constraints of this presentation, I will be presenting key observations from Isla and Lismore. For this study, we collected orientated samples at the Rouval foreshore platform Isla and Aongarb Lismore, in transects starting at the dike contact margin outwards perpendicular to the dike margin, along with sampling the dike's chilled margins and core. Carbon-coated thin sections orientated on the XY, ZY and XZ planes relative to the dike margins were scanned to create large area 1 mm square 700 magnification SEM BSE, CL and EBSD maps. The microfractures were then manually identified and traced from the layered area maps within CorelDRAW, with textural associations such as cross-cutting and Y-node interactions used to determine the relative age relations. Microfractures are commonly classified based upon geometric relations to grains, such as transgranular fractures where fractures cross multiple grains. The FratPack toolbox for MATLAB was used to quantify the characteristics of each fracture set, such as fracture orientation, length and intensity, with further statistical analysis carried out within R. Prior to the emplacement of the 2 to 3 metre wide foliatic dyke at Isla, the host rock was competent with negligible fracturing, composed of approximately 90% quartz with less than 10% rounded feldspar grains with no preferred orientation. The transect location was where the host rock contact boundary was visible above the high tide line. The observed fracture interaction suggests that initially near dike parallel transgranular fractures formed. This was then followed by the evolving inter and intragranular fracture sets with the heterogeneously orientated open fractures and the subparallel sealed luminescent fractures. Of the 4 fracture sets, the most significant in terms of total deformation was the heterogeneously orientated open inter/intragranular fractures, which peaked at an observed intensity of 50,000 m⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻ related to the anisotropic thermal expansion and contraction of the quartz grains. The transgranular fractures associated with the earliest stage of deformation, such as dyke tip propagation, ran parallel to the dyke and was constrained within 10 centimetres of the contacts. The sealed luminescent fractures which formed after the first phase of the open inter/intragranular fractures had a very strong preferred orientation. This grid shows the fracture orientation with increasing distance from the contact going downwards and the sample orientation across the top. The first column is the XZ plane, vertical and perpendicular to the dyke, the second the XY and the third the ZY. The preferred orientation was near vertical and perpendicular to the dyke, suggesting that normal compression from the magma overpressured was sufficient to rotate the local sigma free. At Lismore, prior to emplacement of a 1.5 to 2 metre wide foliatic dyke, the host rock was flaggy marble, with approximately 85% calcite, along with some quartz, feldspar and mica, with abundant intergranular fractures, which followed the strong preferred crystal orientation, with the calcite C-axes orientated horizontally. No relative age relations could be interpreted from the fracture interactions, as the emplacement-related mineralization occurred as one event after the fracture generation had ceased. There was a distinct change in mineralization at approximately 2 centimeters from the contact, with the transition from suppressed luminescence to increased luminescence within the mineralized calcites. Of the SEM images, the top row shows the CL and BSE images of microfractures at less than 1 centimeter from the contact, and the bottom row at 42 centimeters from the contact. EBSD analysis demonstrates negligible variation in crystallographic properties such as shape and misorientation between 1 centimeter from the contact and distal to the intrusion. Transgranular fractures greater than 1 millimeter in length were present within 1 centimeter of the contact, running parallel to the contact. The orientation of the inter- and intragranular fractures, however, were strongly controlled by the crystal orientation. The intensity of the fully mineralized fractures decreased in a linear manner away from the contact, with the last observed occurrence at 80 centimeters from the contacts. There was a significant trend in the intensity of the combined open and partially open fractures with distance from the contact. See top right figure with the intensity on the y-axis against distance from the contact. The different coloured points represent sample orientation. Intensity increased with distance from the contact to a peak of 45,000 meters to the -1 at 40 centimeters, then decaying down towards the background levels outwards. This suggests a complex interplay between sources of brittle deformation and healing. There was significant deformation observed associated with processes after the propagation of the dyke tip, primarily associated with anisotropic expansion and contraction of the grains, and the dyke normal compression from magma overpressure. There is commonly a disparity between the observed dyke shape and the elliptical opening predicted by linear elasticity theory, with thickness being more consistent over the central portion of the dyke and tapering restricted to the dyke tips. Modelling within Vancaron and Heriomus 2017 suggests that increasing viscosity and plasticity can explain some of the disparity. The microfracturing induced reduction in Young's modulus, shear modulus, and increasing propensity towards inelastic deformation after the propagation of the dyke tip may explain some of the disparity within marbles and quartzites. Our findings suggest that within marbles and quartzites, initial propagation of the dyke tip was tensile elastic in nature, that deformation associated with grain scale anisotropic expansion and contraction can be very significant and should be taken into consideration within further models, and that overpressure can be significant enough to cause localized sigma 2 and 3 to flip. I am currently on track to submit my thesis spring this year, so I'm looking for a postdoc from then onwards. Many thanks for listening to my work.